So in the previous video, we talked about the properties of matter that we're focusing on. Now we're going to talk about some changes that occur in matter. Matter is constantly changing regardless of what type of matter it is. It will always go through changes. That's something we just need to keep in mind. Now there's two key types of changes that we focus on in matter. There's physical changes and chemical changes. Regardless of which type is occurring, we need to know that energy is always involved in any of these changes. It's either being absorbed or it's being released in some way. Let's first talk about physical changes. Physical changes is a change in a matter's property, but not what makes it up. So think of tearing, melting, dissolving. These are all changing what substance is. So for example, here we have a metal being melted. It's going from one state to another. You're changing the property of its state, but it's still the same metal. Think about tearing. If you tear a piece of paper, the two pieces you have afterwards are still the same type of paper. You've just changed how it is, not what it is. So think of physical properties as a change in how. Think how. Dissolving's a funny one. A lot of people think this is a chemical change, but it's a physical one. If I dissolve salt into water, I've only changed the fact that its state. It's in a dissolved state. I can easily get the salt back by evaporating all the water, and then I'm left with the salt. It'll recrystallize and be left after all the water has evaporated away. Chemical changes, on the other hand, are changes in matter that produce a different substance than you before. You're changing what the substance is, what the matter is. So, for example, burning, milk souring, iron rusting. These are all chemical changes. So if I look at this piece of this engine block here, you'll notice on the top half right here, there's a bunch of rust. This engine block's not going to be useful anymore because we've changed this top half to something else. It's no longer the iron or steel that we had down here. This part here is still the steel, which is durable and resistant to corrosion and will resist heat. But this rusted out part up here now is much more brittle and it won't stand up to heat as well. And it's now no longer as useful of a material because we've changed what it is as a chemical change. Chemical changes are also called chemical reactions. That's what term we're going to use primarily in this class. And a couple of things to remember about chemical reactions. We have substances that we have before the chemical reaction. They're the things that we have present at the start, and we call those reactants. You can think of those as the ingredients for a chemical reaction. And then the new substances that you have at the end that are created, we call those products. That's what you end up with. That's what you can think of that as what's trying to be made in a chemical reaction. And there's clues that we can look for to tell us that a chemical reaction is occurring. First of all, we have transfer of energy. This can be in the form of heat or light. So, for example, those instant heat packs that you might have, you squish them or and you hear a crack, and it all of a sudden will start giving off a bunch of heat. It's giving off heat. Also, glow sticks for giving off light. It's just like the heating pack, you crack the glow stick, which breaks a little capsule inside of it and allows the two chemicals to mix, and they give off a bunch of light. That tells you a chemical reaction is occurring. Also, a change in color is another indicator of chemical reaction. So, for example, when you bleach your clothes, you have changed the color of the threads of your clothes, and you can't get that color back. You've changed them chemically. Also, you can have a production of a gas. You'll see this through bubbling. So, if you take baking soda and put it into vinegar, it starts giving off a bunch of bubbles. The bubbles are carbon dioxide gas being given off as it's forming. That tells you that a chemical reaction is occurring. And then another one that we're going to be expected to know is formation of a precipitate. A precipitate is a solid that forms in a liquid mixture. So think of this example here. You have curds forming in milk during cheese production. You have this milk, which is a mixture, and you start to get these solids that form. The curds are a precipitate that's forming during this cheese production. They use the curds to make the cheese. Now, it's important to know that these are only clues and don't always mean that a chemical reaction occurs. For example, you can get bubbling when you boil water, but boiling water is a physical change. You're changing the state of the water, but it's still water. It's still H2O, just after you're done boiling it, it's now in a gas form instead of a liquid form. So typically you want to look for two or more of these to help you know that there's a chemical reaction occurring. Now, chemists will use a chemical symbol to help represent the elements and chemical formulas involved in a chemical reaction. And these chemical symbols are always either one or two letters long. If it's one letter, that one letter is capitalized. If it's two letters, the first letter is capitalized and the second one is lowercase. So we have O, N, Na, Cl, C. These are all just one element. O is oxygen and nitrogen, Na sodium, Cl chlorine, and C is carbon. Now we can put them together to make a compound which is two or more elements combined. So here we have H2O, water.